Hi everyone, I'm Miss H, and today we're going to be looking at compound names and formulas. Specifically, we are looking at how we name ionic and covalent compounds. We are not going to deal with the naming of metallic compounds. This is also a basic introductory level course, so we are not going to be dealing with any of the transition metals and having to name any of those. We're just going to be sticking with the very basic uh, naming and formula writing for the kind of introductory level. So the first thing when we write compound names, typically the element that is furthest to the left goes first. There are some exceptions to this with hydrogen, but generally speaking, the element that is furthest to the left will go first. The ending on the second element will be changed to "ide," so you will drop everything but the first syllable and replace all of the additional syllables with "ide." Now, if you're using a polyatomic ion, you are not going to make any changes to that name. You're just going to write it exactly as it is on the reference table or on your reference guide. When we are dealing with covalent compounds, those can form more than one type of more than one type of molecule. So they need to have prefixes on them in order to tell us which molecule it is that we're dealing with, because carbon monoxide and carbon dioxide are very different things, but they are both combinations of carbon and oxygen. So with those, the prefixes for 1 through 10 are listed on the screen for you. Mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Now, sometimes that last vowel is changed based on what the first letter of the element is, but we'll kind of deal with that in just a minute when we start looking at some examples. So we have 5 examples here. Some of these are ionic and some of these are covalent. So if we take a look at the first one, this is one that you should be very familiar with. I know that this is an ionic compound because Na is a metal. When I have an ionic compound, I don't need to use prefixes. So if I look at my periodic table, I'll see that Na is sodium. And if I look at the periodic table, I see that Cl is chlorine, but I'm going to drop everything after the first chlor syllable and change it from chlorine to chloride. So again, I've dropped everything after the first syllable and replaced it with "ide." The second one, neither of those are metals, so I know that it is a covalent compound. Now, one thing I did forget to mention on the previous slide is that when you only have one copy of the first element, you do not need to use a prefix on that. So this will just be carbon, not monocarbon. Oops. So we have carbon, and then I need a prefix that tells me that I have 2 oxygens. So I'm going to use the prefix di. And then again, I'm going to drop everything after the ox part of oxygen because I only keep the first syllable, and I change the rest of it to "ide." So this is carbon dioxide, something again that you're all very familiar with. Another one that you're very familiar with is H2O, which you most commonly call water, but we want to know what the actual chemical name of H2O is. So again, neither of these are metals, so I'm going to go ahead and assume that this is a covalent compound. Since I have 2 of the first element, I do need a prefix this time, so I will use di in front of the word hydrogen. Now again, remember the first element, we don't change anything about it except possibly to add a prefix in the front. Then I need to add something to tell me that I only have 1 oxygen. So that's going to be mono, and then it's oxide. So it is dihydrogen monoxide. Again, this is one of those places where we change that last vowel because of it being oxygen. And so instead of doubling that, it's just oxide, so monoxide. For number 4, we don't see any metals here, but what we do see are 2 polyatomic ions. For this introductory level class, if you see more than 2 capital letters, that means that you are going to need to look at your reference table at the polyatomic ions. Anything that we are going to be doing in this class is only going to be dealing with naming of simple compounds that contain 2 elements or 2 ions. So I can look at my periodic table, I can look at the reference table side of it, and I can see that NH4 is ammonium. And OH is hydroxide. If it had just been the O, it would have been oxide, and if it had just been the H, it would have been hydride. But when you have the OH combination, that is hydroxide. So again, if you see more than 2 capital letters, you know you need to look at your polyatomic ions list. This last one up here, number 5, is K2SO4. So I know that this is also ionic. Number 4 was ionic because it involved polyatomic ions. Number 5 is also ionic because K is a metal and SO4 is a polyatomic. So again, polyatomic ions and metals are always going to be in ionic compounds for the purposes of this class. So K2 is going to be potassium. I don't need the dye in the front. I don't need the dye in the front because this is ionic, not covalent. So K2SO4, potassium and sulfate are only going to form one type of relationship. They cannot form more than one type of relationship. Okay. So again, this is going to be potassium sulfate because SO4 is sulfate on the polyatomic ions chart. Once again, to review, if it starts with a metal, or if it has more than 2 capital letters, it is an ionic compound. You do not use prefixes. If it only has 2 capital letters and none of them are metals, you need to use prefixes because it is a covalent compound and those elements can form more than one ratio. If you have more than one of the first element, you use a prefix. If you only have one of the first element, you don't use a prefix, but you'll still use a prefix on the second one, regardless of how many you have. So then when it comes to writing the formulas, for covalent compounds, it's very easy because of the prefixes. The prefixes tell you exactly what the subscripts are going to be. We do not make any changes to those subscripts. Even if it can be reduced, we do not reduce it because the different covalent compounds are going to have different properties. On ionic, we have to use what's called the crisscross method. So with the crisscross method, you look at what the ion charge on the element is, and then you give that number to the other one. If it is a polyatomic ion, you want to make sure you keep that in parentheses. Again, you might not see that on an answer choice or in a final answer if it just has one copy of it, but it's a good, easy way to remind us that it is a polyatomic ion, so we want to keep it together. So here we see again some examples. The first one says carbon monoxide. The fact that it has that prefix mono tells us that this is a covalent compound. So I'm going to only be looking at my non-metals. If I look at the periodic table, I see that carbon is represented by a C. And if I take off this prefix here, then I can see that my element that I'm left with is oxide, which is oxygen. And since it's mono, I only have one of them. So this will typically be written as just CO, carbon monoxide. When we only have one of something, we don't typically write the subscript. So the next one is calcium fluoride. I don't see any prefixes, so that means my first one should be a metal, and my second one should be a non-metal. Again, the exception to this being if I have polyatomic ions. So for this one, I'm actually going to use 2 different colors to help you see how that crisscross method works. So if I look at calcium on the periodic table, I can see that it has a +2 ion charge. And if I look at fluoride, which becomes fluorine, I can see that it has a -1 ion charge. So I'm going to drop this 2 over here and this 1 over here. That's the crisscross. And so I end up with Ca and a 1 from the F, and then F with a 2 from the Ca, which then is going to be more commonly written as CaF2. So again, typically when we only have one of them, we don't bother writing the subscript like we did not in the calcium. If you leave the 1 there, it's not incorrect. It's just not something that you'd expect to see on, say, a multiple choice answer. With number 3, we see we have prefixes again, so we know we're going to be dealing with a covalent compound and not have to worry about looking at our metals. So if I take off this prefix here, I can look for nitrogen is an N, and since it says di, that means I have 2 of them. And if I take off the prefix, that leaves me with oxide, so oxygen, and that's a 3. So again, we don't reduce here, and because neither of these are 1s, we will leave it written exactly as is. The next one down is ammonium sulfide. So ammonium is going to be a polyatomic ion, as we saw on the previous page. Now, most of the time, we can tell our polyatomic ions because they will end in ate or ite, ATE or ITE. In our class, it will typically always be 8. But ammonium and hydroxide are the 2 exceptions to that. So ammonium is always going to be the cation, and so it will always be written first, and then hydroxide is the only confusing one where it's the second word and it ends in "ide," and that just has to do with how long those compounds have been known about compared to most of the others. So they didn't follow the same naming convention. So ammonium is NH4, and it has a +1 charge. And then sulfur is the element that we're looking at for that one, and that has a -2. So then I can do my crisscross, and I will end up with NH4 2S. Again, though we don't have to bother to write the 1 on the S. The last one here is going to be aluminum oxide. I know that aluminum is a metal, so I'm going to do my crisscross again. So Al has a +3. Oxygen has a -2, so when I do my crisscross, I end up with Al2O3. And now some of you might be wondering why I didn't put the negative symbols down there, because the subscripts are giving us counts, so they can't be negative, they can only be positive. So just remember that subscripts are always positive, and that kind of helps to make you forget about the positive negative thing at the top. I hope that you found this helpful for figuring out how to write formulas and names, and that you have a wonderful day.